Hi everyone. In this session we shall continue with the problems on resultant of non-concurrent force system. So let us take up the next problem, that is find the equilibrium of the four forces acting on a plate. So the given figure is like this, which consists of a plate whose side A, B, C, D So this is the given problem. A plate consists of four forces. One is 125 Newton, second one is 100 Newton, third force is 75 Newton and fourth force is 200 Newton. Now we shall find out the equilibrium of this four forces system. So for that, first we shall resolve this given force of magnitude 125 Newton, and we need to find out the inclination angle. So instead of inclination angle, here they have given the value of slope. Using the slope value we shall find out the inclination angle. So to take up with, let us consider this inclination angle as theta. So if this is theta, this is also is equal to theta. So on resolving, this 125 Newton force, the x component Fx is equal to 125 cos theta, and this y component Fy is equal to 125 sin theta. So to find out this theta, let us consider the slope So for this theta, this is the opposite side and this is the adjacent side. So we shall consider tan theta is equal to 4 divided by 3. So theta is equal to tan inverse of 4 divided by 3. So which will going to give a value of 53.13 degree. Now, so this theta is equal to 53.13. Now let us find out summation of Fx and Fy. So summation of Fx is nothing but the algebraic sum of all the horizontal components. So first let us take up this 125 Newton force, whose horizontal component is 125 cos 53.13 The second force is a vertical force. Third force, that is 75 Newton, which is acting towards left. So that is minus 75. This will going to give a value of 0. Next, summation of Fy is equal to, let us take up the vertical component of this force, that is 125 sine 53.13. Second force is a vertical force, that is 100, which is acting vertically upwards, and the next vertical force is the 200 Newton force, which is acting downwards, that is minus 200. So this will also going to give a value of 0. Since the value of Fx and Fy is equal to 0, directly the value of resultant is also 0. Here in this case we are finding the equilibrium of the four forces system. See, since the value of resultant is 0, that means the translatory effect of these forces on this system is 0. The resultant can be a moment which will produce the same effect anywhere on this system. So hence let us consider the moment about this 125 Newton force. Therefore, the resultant can be a moment which will be same anywhere on this system of forces. Therefore, taking moment about the point of application of 125 Newton force which is equal to, so the moment produced by both the horizontal and the vertical component of 125 Newton force is 0 because both the components are acting on the same point. Next, let us consider this 100 Newton force, that is 100 multiplied by the perpendicular distance between the line of action of the force and the point. So this is the point where we are finding the moment. So the perpendicular distance between these two is 2 meters, and this force will going to produce a clockwise movement about that point. So that's why it is positive. Next, let us consider this 75 Newton force. So this is the line of action of the force and this is the point. So this will become the perpendicular distance between the line of action of the force and the point. So this distance is given as 2 meter. And this force will going to produce a clockwise moment about this point. Again, this is positive. Next, let us consider this 200 Newton force multiplied by the perpendicular distance between the point and the force is 1 meter. And this force is producing an anti-clockwise moment about this point. So that's why it is negative. So this will going to give a value of 150 Newton meter clockwise. So now let us consider the fourth problem. So which states that four forces acting on a triangle ABC as shown in the figure, the sum of moment of these forces at C is 2000 Newton mm clockwise if the resultant of force system is in horizontal direction find its magnitude and point of application. So the given figure is like this. It consists of a force P and Q at point A and a 10 Newton force at point C and 20 Newton force. This angle is given as 60 degree. So this side is given as 120 mm and this is 160 mm. So to solve this problem, first we shall write what is the given data So the given data is that there are four forces, one is P, Q, another one is 10 Newton and 20 Newton. The sum of moment of these forces about the point C is, sum of the moment of these forces about point C is 2000 Newton mm clockwise, that is positive, and if the resultant of this force system is in horizontal direction. So what do you mean by this? Sum of the forces or the algebraic sum of all the horizontal components of this system will be equal to the resultant, because they have given that the resultant of the force system is in horizontal direction. So through this we can directly write this summation of Fy is equal to 0. Then we need to find out what is the magnitude of these forces. that is what is P, what is Q, and the point of application of this resultant. So therefore, we shall consider this, that is, we know that summation of Fy is equal to 0. So let us consider all the vertical forces now. So at point A, there is a upward vertical force Q. Next, here there is a 20 Newton force which is acting vertically downwards, and at this point C, there is a inclined force 10 Newton. So first we shall resolve this given force, that is, the direction of the given force will going to lie in the fourth quadrant. So first we shall find out this inclination angle. For that, use this triangle concept. So for this theta, I know this opposite side, I know this adjacent side. So you can use tan inverse of opposite side is 120 and the adjacent side is 160. So this will going to give the value of theta as 36.87 degree. So the x component of which is 10 cos 36.87 and the vertical component is 10 sin 36.87. So now Q minus 20 minus 10 sin 36.87, which is equal to 0. So on solving this, we will going to get the value of Q as 26 Newton. Next, let us consider the second equation, that is summation of Fx is equal to R. So now we shall consider all the horizontal forces, that is at A there is a horizontal force P. Next, again the horizontal component of this 10 Newton force, that is 10 cos 36.87 is equal to R. See, again in this case I do not know the value of P as well as I do not know the value of R. So let us keep this as equation 1. And also we know that the summation of the moment about point C is equal to 2000 Newton mm clockwise. So now in order to solve this, we shall consider moment of all the individual forces about point C. Now the moment produced by this 10 Newton force, that means by both horizontal component and the vertical component is 0 about point C. Now let us consider the moment of the remaining forces, that is the first force is P multiplied by the perpendicular distance between the line of action of the force and the point. So that is 120, and this force will going to produce a clockwise moment, that is positive. Next, Q, the value of which we got is 26 Newton multiplied by the perpendicular distance between the line of action of the force and the point is 160, and this force will also going to produce a clockwise moment. Next, there is a 20 Newton force multiplied by the perpendicular distance between the point and the force is 160 again, and this will going to produce anti-clockwise moment about this point C. So which is equal to 2000. So on solving this, we will going to get the value of P as 8.68 Newton. Now we shall substitute this value of P in equation 1. We will going to get the value of R. So on solving this, we get the value of R as 16.66 Newton. Now we got the magnitude of the resultant. Now we shall find out the point of application of this resultant. So we know that point of application of the resultant is equal to D, which is equal to moment about C divided by the resultant. So which is equal to 2000 divided by the value of R is 16.66. So we got the value of D as 120.04 mm. So to represent this, we got the value of, so we already got the resultant value and which is acting in the horizontal direction, which has a magnitude of 16.66 Newton, and with respect to point C, it is acting at a distance of 120.04 mm. So now let us consider the next problem. Which states that three forces and a couple are applied to a bracket as shown in figure. Determine the moment M if the line of action of this resultant, line of action of this of these forces is to pass through B, compute the resultant of three forces moment. So the given figure is so first we shall write down the given data. So there are three forces and a couple. There are three forces and a couple which are applied on this bracket is as shown in the figure. So we need to find out the value of this moment m if the line of action of the resultant of these forces is to pass through B. That means the moment should, the line of action of the resultant of all these forces should pass through this point B. So we should find out the value of resultant of these three forces and the moment. So it is given that line of action of this resultant moment should pass through B. That means if I consider the moment about point B of all the forces will be equal to the moment of the resultant, will be equal to moment of the resultant. And if the line of action of all these forces are passing through point B, then moment of the resultant about point B is equal to 0, because the resultant is passing through point B. If I consider the same, the moment about point B of this resultant, since the line of action of the resultant and the point are same, that means that value will be equal to 0. So we know that we got the first hint as sum of moment of all the forces about point B will be equal to moment of the resultant. Why? Because they said that the magnitude of the resultant is, or the line of action of the resultant is passing through point B. So now, so they have given that in this question we need to find out what is the value of this moment, and they also mentioned that determine the moment m if the line of action of the resultant of these forces is to pass through B. That means we need to find out what is the value of the resultant, and also it is mentioned that the line of action of the resultant of these forces is to pass through B. That means if I consider the moment of these forces, all these forces about point B, that will be is equal to moment of the resultant. Why? Because here the line of action of the resultant force is passing through B. So, and again the value of this moment about point B will become 0, because the line of action of the resultant force and the point are same. So now we shall consider this is equal to moment of the resultant. So we shall consider the moment of each individual forces about point B. So before that there is an inclined force, that is 125 Newton. So we shall resolve this. The x component will become 125 cos 60 and y component will become 125 sin 60. So the moment produced by both these components about point B is 0. So now let us consider at point A there is a force of 50 Newton multiplied by the perpendicular distance between the line of action of the force and the point is given as 300 mm, and this force is producing a anti-clockwise movement about this point, and again there is a couple movement, the direction of which is anti-clockwise. Again this can be written as minus m, and there is a 200 Newton force at point B which is producing a clockwise movement, that is 200 multiplied by the perpendicular distance between the line of action of the force and the point is given as 200, which is equal to the moment of the resultant. So on solving this we will going to get the value of moment. So moment about, so this can be equated to 0. So the value of m as 25,000 Newton mm clockwise. So we got this value. Next we shall consider summation of fx and fy in order to find out the magnitude of the resultant. So summation of fx is equal to, so at point A there is no horizontal force, at point B 125 cos 60, and at point C there is a left moving force of magnitude 200. So on solving this we will get the value of fx as minus 137.5 Newton, which is towards left. Next consider summation of Fy, which is equal to, at point A there is a vertically downward force minus 50, at B upward force 125 sin 60. So on solving this again we will get the value of which is 58.25 Newton, which is upwards. So using these two we shall find out the value of the resultant. So that means we know that R is equal to square root of summation of fx whole square plus summation of fy whole square, which is equal to we got the value of R as 149.32 Newton. We shall find out the direction of the resultant, that means the value of theta, which is equal to tan inverse of mod of summation of Fy by summation of Fx, which is equal to tan inverse of Fy is 58.25 divided by 137.5, which will going to give the direction of the resultant as 22.95 degree. So now let us take up the next problem. So which states that 4 forces acts on a 700 mm by 375 plate. So find the resultant of these forces second sub question, locate the point where the line of action of the resultant intercept the edge AB of the plate. So the given figure is so let us consider the angle of this as theta 2 and this as theta 1. At point C, there is horizontal force of 160 Newton, and at point D, there is a vertical upward force of 600 Newton. So in the given question, the figure consists of 4 forces. At point A there is 500 Newton force, at point B there is 340 Newton force, at point C 760 Newton, and at point D 600 Newton. So in the first question they asked you to find out the resultant of these forces, that is we need to find out the value of R. Next, locate the point where the line of action of the resultant intercept the edge AB. Intercept the edge AB. That means you should consider the moment of all these forces with respect to point A or B. Okay. In order to find out this, first we need to resolve this given inclined forces. So for that we need the inclination angle. So in order to find out this value of theta 1 and theta 2, so if this is theta 1, this is also theta 1. So this becomes theta 2. So first find out the value of theta 1 and theta 2. Theta 1 will be equal to, I know this opposite side and the adjacent side. So theta 1 will be equal to tan inverse of 375 divided by 500, and theta 2 will be equal to tan inverse of again 375 divided by 200. So on solving we will going to get the value of theta 1 as 36.86 degree and the value of theta 2 as 61.92 degree. So in order to find out the resultant, we need the value of fx, summation of fx and fy. So first we shall consider summation of fx. which is equal to, so at point A, first we shall resolve this given force. So the direction of which will going to lie in the second quadrant. So the horizontal component is 500 cos theta 1 is 36.86 and the vertical component is 500 sin 36.86. So at point B there is a 340 Newton force whose direction will going to lie in the first quadrant. So the x component becomes 340 cos 61.92 and the vertical component becomes 340 sin 61.92. So summation of Fx will be equal to, so at point A, horizontal force of magnitude 500 cos 36.86 which is acting towards left, that is why it is negative. Next at point B there is a right moving horizontal component, that is 340 cos 61.92 and at point C there is a left moving force of magnitude 760 which is equal to minus 760. So which will going to give the value of which as 1199.90 Newton, so which is positive, that is upwards. Now using this we shall find out the value of R. So to find out the resultant, we know that R is equal to square root of summation of Fx whole square plus summation of Fy whole square. So Fx is minus 1000.01 whole square plus Fy is so on solving this we will get the value of resultant as 1561.97 Newton. Now we got the resultant. Now we need to locate the point where the line of action of the resultant will going to intercept this A and B. So for that we shall consider the moment of all the individual forces about point A or B. So before that, find out the direction of the resultant, that is theta r is equal to tan inverse of mod of summation of Fy divided by summation of Fx. So which is equal to tan inverse of, we got the value of Fy as, and Fx as 1000.01. So on solving this we will get the direction of the resultant, so which gives a value of 50.19 degree. So to find out this, the point where the line of action of the resultant will going to intercept this edge AB, we shall consider the moment of all the individual forces about point A, which is equal to, so the moment produced by both these forces is 0 because the line of action of these forces and the point are same. Next at B, the moment produced by this 340 cos 61.92 is also 0 because the line of action of this force and the point are in the same line. In a similar way, the moment produced by this 600 Newton force is also 0 about point A because this is also in same line of action with A. So let us consider only the moment produced by this 340 sin 61.92 and 760 Newton. So 340 sine 61.92 multiplied by the perpendicular distance between line of action of the force and the point is 700 mm, and this will going to produce a anti-clockwise movement about point A, and at C there is a 760 Newton force multiplied by the perpendicular distance between line of action of the force and the point is 375 mm, and this force is going to produce a clockwise movement about A, that is positive. So on solving this, we will going to get the value of which as 75,014.688 Newton mm clockwise. So we shall locate the point of application of this moment or the resultant, which is equal to D with respect to the edge AB. So summation of moment about A divided by the resultant. So which is equal to the value of R is which is equal to 48.02 mm, and we shall place this resultant with respect to edge AB. That means we need to find out the value of x-intercept and y-intercept. So x-intercept is equal to sum of the moment about point A divided by summation of Fy, and y-intercept will be equal to summation of moment about A divided by summation of Fx. Fy is 1199.90. So on solving this, we will going to get the value of x-intercept as 62.51 mm and y-intercept as 75.01 mm. So to represent this, so this is the given plate. We need to represent it with respect to edge AB. So we got the value of Fx as negative and Fy as positive. So that means the direction of the resultant will going to lie in the second quadrant. So which may be this or this, and we got the value of moment as clockwise. That means the considered direction should produce a clockwise moment about A. So this force will going to produce a clockwise moment about this point A. So let us consider this. So for which the value of R we got is 1561.97 Newton, and the direction of which is theta, which is equal to 50.19 degree, and this is the y-intercept, this is B, and this is its x-intercept.